Hello Chemistry, this is the video demo that's titled Specific Heat. We are going to be heating up two substances. All right, we're going to be adding heat energy to them today, and then we're going to be watching how they respond with their temperature readings, okay? So we've talked a lot about how things gain energy, right? And we record that as a temperature change, right? But not all substances respond to heat in the same way. So for instance, you've probably heated water on a stove before and seen that the metal pan gets hot much more quickly than the water does, right? Even though they're absorbing the same amount of heat, the water responds more slowly, or it takes more heat to change water's temperature than it does the metal pan in that case. And it's going to be similar to the experiment that we're going to do today with, we have water here on the right, and we have alcohol on the left, right? And they're in these black cans that are going to absorb radiant energy from our heat lamp up above here, and we're going to see how they respond to temperature change, okay? So the first thing that we're going to do is we're going to stick our channel 2, which is the blue reading, into our water like this. There it goes. And then we're going to do the same thing here with into our alcohol. All right. I'm just going to get it to sit up here like this. Okay, good enough. All right, so there we go, there and there. All right, and now let's take a look at these temperature readings. All right, they're both about the same right now because they've been sitting here on the shelf or on the table for a while, and they've come to thermal equilibrium room temperature of about 24.8 degrees. I guess it's a little warm in here today. All right, we're going to go ahead and turn our heat lamp on. And then we're going to record our temperature change, right? This heat lamp is going to supply energy to both cans here. Okay, so we've been sitting here for about 2 minutes now, and we can see that the temperature of our alcohol has increased a little bit more than our temperature of our water has. Right? So we're going to just let this sit here and continue to accumulate heat energy, and we're going to monitor the temperature of the alcohol here in red and the water in blue. All right, guys, I'm speeding this up by fast forwarding a little bit here. It's been about 5 minutes now, and hopefully you see that our alcohol is continuing to increase in temperature at a faster rate than the water is. The water has only gone up by like 0.2 degrees. And we're zeroing in on almost a whole degree change in our alcohol. We're going to keep this going for another couple minutes. I'll keep fast forwarding, and then we'll talk a little bit at the end. Class, it's been about 15 minutes now, and you can see that our alcohol is up to 26.1, and our water is only up to 25.3. Right, so we're supplying these with the same amount of heat. It's the same heat source right above it, right? But the alcohol is responding with a higher temperature change. And so we need to be thinking about what this means in terms of how much energy is required to change the temperature of methanol, which is the kind of alcohol we're using, or how much energy change is required to change the temperature of water over here. Are they the same? Are they different? What does this mean? Okay, chemistry. It's been about 20 minutes now, and you can see, I hope, that our alcohol has raised about 2 degrees more than our water has, given the same amount of heat. Okay, and so this is supposed to illustrate to us that heat and temperature are related to each other, but they are not the same thing, right? The same amount of heat energy affects alcohol in a different way to a different magnitude, and the same amount of heat energy affects the water. And the property that quantifies this difference is called specific heat. Right? The alcohol here has a lower specific heat. That means that it takes less energy from the lamp to increase its temperature, whereas the water has a higher specific heat, meaning that the water takes more energy to change the temperature. The higher the specific heat, the more energy or calories is required to change that sample of water. Okay?